Hello learners, today we are going to talk about the gradient descent. Gradient descent is a basic concept of machine learning and deep learning. It is highly used in the deep learning, and the idea behind gradient descent is to optimize the cost. So before going to the gradient descent, we must know what is linear function and what is the cost function. And one of the important cost function is mean square error. So how do we use gradient descent? Before that, we are going to refresh the concept of linear regression. Regression is basically computing the target value based on the independent predictors. Like we have the heights of the students and we need to predict the height of another student. So we will draw a graph of height of student and then we will use a prediction line for deciding the new based on the data available. We predict the height of the students. So what we are doing in linear regression, a number of independent variables are there and the type of relationship is independent and dependent variable. When we talk about the simple regression, in that case we have only one dependent variable, that is weight of the student, and based on that weight we need to predict the height of the student. So this is one of the method, simple regression. When we talk about the multiple regression have more than one independent variable and based on this we compute the value of y. So when we talk about simple regression, this is the weight of the student and based on this weight we need to predict the height of the student. So it is nothing but a equation of a line where this theta 0 and theta 1 are the weights known as the weights, and this theta 1 are theta 1 is known as the gradient. Now we will move to detailing of cost function. So what is the objective of cost function? We need to identify the best fit line. We need to identify this best fit line so that our prediction error is minimum. How it will be done? We calculate the prediction error. We calculate the error like predicted value and the actual value. Based on this, we compute the error. If this error, our cost function, objective of the cost function is to minimize the error between predicted value and actual value. So what is the minimum cost function? It is calculating the predicted value and the actual. This is the predicted value and this is the actual value. So this error is known as the prediction error. If this prediction error is less, our algorithm is computing exact values. For this purpose, what we are doing, we are taking this square of this prediction error. Why? Because sometimes it is possible that prediction error is at the positive side of the actual value, or predicted value will be the negative side of the actual value. In this case, we need to take the square. So what is the objective of cost function? Or objective of the cost function is to optimize the error and we should get the best fit line. So this prediction values is computed as the square of predicted value minus actual value, and this is the whole average error is calculated whole square. Why this is whole square? As I earlier mentioned, some errors, some predicted values are at the positive side and some may be on the negative side. If we did not take a square, that they will be cancelled out and we get this minimum value drawn. That is for this cost function has the square value and the average of this. So the objective of the gradient descent algorithm is to optimize the value of the cost function to get the minimum cost function value. How do we do? Then we will see. Okay, so I have already explained you. We used to update the value of the weights theta 0 and theta 1 to reduce the MSE because we want to get the best fit line. So how we are doing? We are starting with simple values, value initialization of theta and theta 0. and iteratively we compute the value of theta 0 and theta 1 to reduce the cost function. Now the gradient descent helps in computing the next values. What is the function of gradient descent? It helps in the computing the next value so that we can get the best possible value. So as I already told, the objective is to minimize the value. So we use some of the terms in gradient descent, that is derivatives and the learning rate. So what is basically a learning rate? Think of a pit where we are going. Think of the pit where we are going. If we take this analogy, if we are moving downwards, then our objective is to reach the bottom of the pit. It depends on how many steps we take. If we take the small steps, it will take long time to reach the bottom of the pit. If we take the large step, or if we jump like this, we may from here to here, here to here, here to here, we may not reach to the bottom of the pit and we may overlook this. So this learning rate decides basically the how many steps we require to reach to the minimum of the error. So this is very important factor, and this we assume. So if it is taking the large step, algorithm is fast, but we may not reach to the local minima. This is called local minima in case of algorithm. And if we take two small steps, so it will take more time to reach to the local minima. There are two types of local. This graph shows this side is the cost function, and according this the value of the we are drawing. So this is the minimum cost value of the cost function against theta 0 and theta 1. Here the dependent value is only one variable. So what we are doing, this is the convex graph where the minima is only one. So wherever we start, we will reach to the minima if we have taken the value of alpha wisely. But if it is a non-convex graph, in that case we have various minima. This is the global minima, that means the minimum value of whole graph, and this is the local minima. If we start from here, we may reach to this value, and we assume that this is the minimum value of cost function, and we may reach to the best possible line, but in actuality the global minima is this. If we start from here, we may reach to the global minima. So it depends on from where we are starting. These are the example of the selecting alpha. So if we reach here, if we select alpha here, we will reach to the global minima, because this is the global only one minima in this graph. We can see graph is 3D graph, two values dependent on two weights theta 0 and theta 1, and this is j theta. If we see another graph, it has various local minima also, and it depends on the direction we are selecting. Correct? So it depends on the direction also. There are two things important in optimizing the cost function. One is the how many steps we are taking, and the second we are talking about in which direction we are going. So the direction is decided by the derivatives. Direction is decided by the theta 1. Like this is, if we assume in a simple mathematics, this is the equation of the line. If we take only one dependent variable and we need to decide the predicted value, in that case this equation is the simple line equation where x is dependent variable and y we are predicting. So this theta 1 will be y is equal to mx plus c. So c will be your intercept theta 0 and theta 1 will be dy by dx. So this first level differential will decide the direction in which direction we are going. And based on this we are calculating. So what is the cost function? By the way, the cost function is defined as our predicted value minus actual value. We had done nothing. Our predicted value and our actual value. So our objective of gradient descent algorithm is to minimize the value of cost function based on the theta 0 and theta 1. So we need to compute the theta 0 and theta 1 iteratively. So how do we compute? If we compute it by taking the differential, we define a gradient descent formula where any theta I or theta j can be computed by differentiating the cost function. This is the cost function. Now this is the gradient descent formula. Okay, so if we theta 0, what is theta 0? Theta 0 is without value of x multiplication, and theta 1 is multiplied by x. So when we take the theta 0, it will have only twice of this, but when we take the theta 1, it will be multiplied by xi also. For theta 0, for example, for theta 0, this x will not be there and we have theta 0 minus y. But theta 1, we will have this x. Understood? This is simple differentiation we used to do. So what we are doing, we are computing maybe the single dependent variable, maybe the multiple dependent variable. If multiple dependent variable, in that case, we have more than 2 thetas. So theta 0 is without multiplication of x, we can call it x0, or this is equal to 1, and then theta 1x, theta 2x and theta 3x and so on, dependent on number of features or number of dependent variable. We compute the gradient descent next theta 0 by using this algorithm. So what we are doing, we are taking this, we are computing this derivatives. This derivative decide the direction in which direction we have to go. Okay, so this is, for example, if we take this example, suppose we have theta 0 is equal to 0.45, theta 1 is equal to 0.75, and we have taken the learning rate. Learning rate is the how many steps, size of the step we moved forward. So if we calculate theta 0 is what? Theta 0 plus minus alpha 1 by m, theta 0 x minus y. So if we calculate, this is derivation of cost function, and if we calculate the theta 1 will be multiplied by x only, because this is theta 1 x. So if we compute the value based on this, we get the predicted value. Got it? We get the predicted value. Now based on this predicted value, we calculate the squared error for each value of y. Okay, this is the formula where we have to sum. We have calculated the error for each value of actual y and predicted y. Then we calculate the average. So this is the average, this is the total error, this is the formula delta by delta A, and this is the theta 0 based next theta 0, and this is the next theta 1 x. So now we calculate the new value of theta 0 and theta 1, that is A and B defined here. So what will be the next formula? 0.42 and 0.73. In this manner, we have to repeat the value. I will repeat this example once again. We, instead of theta 0 and theta 1, we have A and B here. We calculated the predicted value. Based on this predicted value, we calculated the 1 by 2 minus this predicted minus this. This is the cost function. Okay, for each value of x. Now our objective is to minimize the value. So this is the cost function. Then based on this, we calculated the theta 0. For this, theta 0 formula is required, and for this x multiplication is required. Like this, here we have for theta 0 what we have, 1 by m theta h theta 0 minus y, and for theta 1 we require theta 1 minus 1 by 2 this into xi. The same we have calculated here for this. So this minus will be minused from previous value of A and B, and we get the new value of A and B, that is 0.42 and 0.73. Clear? So based using this learning rate, that is 0.01. Okay, clear to all of you? Now we compute the another value. For this new value, we calculate again the value of A and B. And this process is repeated till we get A and B both equal, or error is both are equal to the previous value of the A and B, or error is increasing. So we arrive to at optimal level, and this is the highest accuracy we get. So what we have done in this algorithm, if I explain in a nutshell, the objective is to minimize the cost function. Gradient descent is used not only in the machine learning but also in the deep learning in forward propagation and backward propagation. We will learn. Our objective is to minimize this cost function, and what we have done, we computed iteratively by taking the initial value of theta 0 and theta 1. We computed iteratively. So assumptions are two: initial value of theta 0 and theta 1, that is weights are assumed. Again the learning rate is assumed. So we don't have to calculate the major advantages. Only the initial values are assumed and rest is computed using iterative method of gradient descent algorithm. We don't have to compute the second derivative. Only the first derivative will decide the direction. We don't have to store the matrix also, and it can be slow if we have not selected, can be slow if we have number of dependent variables are more, or we have not selected proper alpha. So maybe the iteration largely depend on the how we have taken the initial value. So hopefully there are various type of descent algorithm, gradient descent algorithm, batch gradient descent, scholastic gradient descent, and mini batch gradient descent. We will talk about these three algorithms in my next video. Hope you understand the concept of gradient descent and how it is useful in optimizing the cost computation. So please do not forget to like and watch my video. Thank you very much.